Well, as I do every time, here's an introduction to my next project. This is a little bit different than some of the previous things I've worked on. This is not an audio piece of gear. It is a Heathkit VTVM, which stands for Vacuum Tube Voltmeter. It's a model IM11 vacuum tube voltmeter. And of course you're probably asking yourself, why do I even want to fix this? I have probably 6 or 8 other nice digital meters and one analog meter here. That's just a battery operated regular analog meter. There are a few advantages that vacuum tube voltmeters have over their digital counterparts. The first is that it has a much higher impedance input than most digital meters have. Most digital meters will get you around, for example, 1 mega ohm if they're good. Sometimes they're less than that, which usually means they're a terrible meter. This can be on, and I don't know the specs of this particular unit, but a good vacuum tube voltmeter can be on the order of 11 to 15 mega ohms, which you're thinking to yourself, when I get up into the mega ohms, does it really matter? But the answer is yes. In some cases, when you're measuring very small currents or voltages, the impedance of the meter can affect the measurement. The meter itself is in pretty decent condition. There is a crack on the, actually it's, yeah, I guess that is a crack, but it's still pretty solid. It's not like it's actually falling apart, but the crack does go all the way through the display, so it's not like I could buff it out or anything like that. But it shouldn't really make much of a difference. Again, this was actually free. This was given to me by my father-in-law, who was into electronics back in his day and now has kind of gotten out of it and really doesn't do much anymore. And he said maybe I'd be able to use some of these things. The cord has been cut, as you can see, and it's missing a screw. I'm hoping I'll be able to either find 2 that are matching here or just one more that looks like this. It's a flathead screw. I don't care if they're Phillips screws, I just want to have 2 matching screws on there. The rest of it's in pretty good condition. The handle's in good shape. The bottom still has its feet and they're actually still serviceable. So all the knobs are intact and the switches work, at least as far as how they feel. And then you got your little adjustments here, so that helps you zero it out. So this does take AC power, which is nice because then you don't have to worry about are your batteries dying or whatever. There is a battery inside of it. I know this because I've looked at other meters, and it's actually used for a DC source to measure the resistance, if you're measuring resistor or any resistance source with this. Oh, well, this actually comes off too, apparently. So that's handy. So I'm going to go ahead and take this apart and start looking at what's going on inside. And well, I've got the meter open. It was very simple, just the one screw that still existed, and just pull it right out, right apart. So you can see the 2 vacuum tubes there. I believe one is basically used as some kind of regulator and the other one actually drives the meter, or the measurement per se. There's a battery in here. This has probably been replaced at some point. The battery is not leaking or anything. It's got a transformer here. You can see the wires were just cut right there. And here's where the power cord went out. It's right there. There's one of the main selector switch here, which I may want to run some contact cleaner on to try and fix that. And some adjustments here on the main board too. You got a AC balance here, which is labeled. You got a DC cal and you got an AC cal. So I'm not sure what those adjustments are for, but I'll have to look at the manual. I think I've been able to find a copy. I'll have to look again to make sure I still have it. And then the actual probe plugs in here. So think the biggest part what I'm going to have to do is just some cleanup. Replace the battery. Even though this looks like a newer battery, it has expired, and considering once I put this together, if it's working right, I may never take it apart, or at least not for a long time. I'd want to, I think, have a fresh battery in there just for that purpose. And probably replace, there's, I believe, 2 capacitors in here. They're going to need to be replaced because they're either oil or paper. I don't know what these are, but they need to go either way. This large one here, there's some ceramic capacitors which are going to be fine, and all these resistors should be fine. There should be no issue with those. And there's another one kind of down in here. You can see it laying there at the bottom, which that's going to be a pain to get out, but anyway. So let me get an inventory of that, and oops, I guess it doesn't sit right if it doesn't have a case on it. Let me get that stuff, and I can continue working on this a little bit later. Well, I'm taking this apart and starting to work on it here a little bit, and I took the tubes out because I'm going to be moving the circuit board around a lot because of the way it's mounted, and I didn't want to damage the tubes in any way. But I wanted to provide some information about the tubes. This one is called a Triad Electronics tube. I'm assuming that's the brand. And the printing up here indicates that it is a 12AU7A, which sounds like a tube model that I'm, kind of heard that kind of thing. I'm not intimately familiar with tube gear, so if this situation isn't working, I really have no way of testing this tube or anything. I can probably just find one of these somewhere and buy it and stick it in here, if that's the case. But it looks okay inside. The pins could probably use a dip in the cleaning solution or something there, spray them off or whatever, just to clean them up. But other than that, it looks okay. So that's that one. And then there's another smaller one here that says product of Daystrom Incorporated. And this indicates that it is a 6AL5 tube, so that's the smaller one. So I'm just sticking those off to the side so that they don't get damaged or lost. And I think the first thing I'm going to do is replace this capacitor and start touching up some solder joints, and probably start getting the new cord wired in too. I have another cord here. Well, I'm working on replacing these capacitors. Now, I've got the one up here done. The soldering on the board is a little bit homegrown here, and I don't know how much effort I want to try to put into fixing it. I could probably tidy it up extremely nicely with the nice desoldering tools that I have, but it would still be a fairly time-consuming process. So I think I'm going to leave it alone unless I find a problem where it's not working. These capacitors have this paper covered wiring covering the leads, and the leads were soldered directly to whatever terminal, in this case this one, and in that case the other one down there. And I don't want to reuse any of this paper insulation or this sheathing here. So what I've actually done is I've actually cut some pieces off of AC electrical wiring from here, and I've actually discarded the internal wire to leave myself with a really nice piece of insulation, which I can then use to cover these leads going where they need to go. So I'm going to do that, and this is good stuff. I mean, this wiring is brand new and this insulation is in really nice shape, so that should be safe to do it that way. So I'm going to do that for this capacitor. The other one mounted directly to the board, so I didn't need to do that. But let me get this installed here real quick. Well, I'm cleaning this battery spring because this is not corrosion, it's just dull and old. So I'm actually going to try and clean it. I do this frequently with electronic parts, especially anything that needs to make good contact. You got to be careful with potentiometers, but most other things you can clean like this, and even knobs and stuff you can clean, and it usually helps So, see how it looks. Well, I am absolutely shocked at how clean this spring got. It literally could be brand new. Honestly, it's apparently copper. I wasn't sure what it was. It looked like some sort of metal with a coating. It may not have any coating at all. It may just be copper with some tarnish on it. But it is absolutely spotless, which is going to make really, really good contact with the battery. So, yay. So I got to install this, get a new battery out, and start putting this thing actually back together. I've done some cleaning on the switches, as you can see here. I've done some cleaning there on these different plates to try and get better contact. We'll see how that goes, but I think it's kind of getting to be time to start reassembling. So let me get this put back together, and pretty soon we'll be ready to give it a test here. Alright, let's fire it up. There's a light here. These switches might still be quite a bit dirty. The negative DC thing seems to be a little flaky. Positive one seems alright. I may have to do some more cleaning on those rotary switches in the back with the different wafers and all that. So I'm going to try measuring DC voltage. I've got a battery here that I'm going to try and measure the voltage on. Oh, there we go. Let's see. I think these switches are still real dirty. It's kind of flaky. I get different things depending on. It's just kind of moving around, and I'm just holding it against the battery there. Either that or I got a bad tube or something. But get it to, that's a little better. So if I'm on the 1.5 volt range, it's reading about a volt on this battery, which I actually metered it out with my digital meter, and it's battery's fine. It's a 1.5 volt battery, but I may have to calibrate this thing. Well, I'm still working on this VTVM that I thought I was kind of done with, but I'm actually going to do a little bit more work on it just to make it as perfect as I can, because this is going to become a fairly essential tool in the workshop for me, especially if I'm working on older equipment where I have to peak a voltage, like an RMS voltage on a receiver or a radio like a tuner or something like that, where the high impedance will come in handy. So I'm actually still working on this. I'm redoing the probe right now because I was trying to calibrate this unit and basically kept running into problems where the probe was apparently the cause of erroneous readings or readings that were jumping around or something like that. So I'm redoing the whole probe. What I've done here is I've actually replaced the wire. I've got my other meter out here to test the resistors inside this probe, since I can't do it with the meter I'm working on, which makes sense. This probe is a rather neat unit, and I didn't really go into detail on it, and I wish I had started a video when it was apart, but it's kind of slipped my mind and I just started working on it. This probe is used for all the measurements, if you'd like, and it's pretty neat because it's got a little switch on the probe here that you flip this lever, and it goes from a straight connection to adding a 1 mega ohm of resistance into the line. And I have to look at the exact manual to see which settings is for what, but one is for DC and ohms. I believe that's the one where they insert 1 mega ohm in, and then I believe the AC readings are just plain. And it looks like someone has already, presuming the former owner, has already marked this with a piece of what looks like whiteout, possibly just a dab of whiteout, and I'm not sure which position that indicates, so I don't know if that helps me very much, but they obviously knew what that meant. I've also done some cleaning on the tip there. As you can see, it's relatively shiny. I don't know what kind of metal this is. It's not steel or iron, not aluminum either. I'm not really sure exactly what that is, but I cleaned it up real nice. I actually soaked this whole tip portion in my sonic cleaner and let it just buzz away, and dirt was flying off of it and everything else. And now the spring is freed up a lot more, and actually I can switch this with one hand rather easily, so that's nice. And then I ended up having to change out the wire on this, which I gotta find the end of this. Well, that's been busted, but I gotta find the end of that. Anyway, I changed out the wire on this probe because I was having a lot of problems with the other wire, and I think it had some breaks inside of it, so I changed that. And the next thing I'm doing here, as I mentioned earlier, is I actually need to replace or do something with the clip on this end. You see how there's a bunch of breaks in the wire here? It's still electrically conductive, but it's not safe either way. And it seems like the last 4 or 5 inches of this wire is very hard, where I can just like crack it, and you hear that? It just kind of cracks. But then once you get to about right here, it's soft and it's pliable, and it can easily bend and everything else. So I don't know what happened to the end of this wire exactly. I don't know if it was heated, or I don't know what would cause it to get like this, where it just easily kind of cracks. The insulation, rather. The electrical is still connected inside the wire itself, but the insulation is cracking, and I'm not sure what causes that. So I'm basically going to take just about 5 inches off the end of this and reattach it to the alligator clip there. That's the next step right now for this. Well, I'm done with the probe finally. I've got this lead repaired and it's working well, and this probe repaired, and I verified it with my current meter. So now it's time to actually do some alignments on this thing. So I'm going to go through the manual here and just talk about it a little bit. Normally I don't like doing manuals here, but this is the test and calibration section. And right here, it says place the instrument in normal operating and turn the plastic screw on the meter face with a screwdriver, while gently tapping the meter face with one finger. The pointer should coincide with the 0 line. So basically what they're saying is using this little screw here, now it's hard for me to show, adjust the meter to 0 there, which I've just done, and it lines up perfectly with the 0 line. So next step is to do the 0 adjustment. Switch it to DC plus and adjust the 0 adjustment. Probably need to leave this on for a few minutes, so I'm going to do that. Alright, so I've let it warm up sufficiently, and so now I'm doing the DC, or the 0 adjustment, which is done on DC plus. There it is. And in theory, you're supposed to be able to switch to DC minus, which I've done, and AC, and have the line remain very close to 0. As you can see, it's nearly perfect. And the only movement of the needle is really because I'm slightly touching the meter itself, not because of any problem. So that's good. Alright, so I'm in DC plus. I'm going to hook up to a battery and calibrate that. Alright, so it says to connect a 1.5 volt battery, which these are actually around 1.6, but the dot is higher than 1.5. So I may have to test this with a more exact source, but right now I'm just doing basic calibration. Plus, the things I'm going to be measuring don't need to be that critical. It's more of a change or peaking or whatever, so I'm getting it as close as I can. It says to set it on the little red dot, which is there, and adjust one of the potentiometers in the back, which is the center one here, and make it line up with the red dot. Of course, every time I move this thing it changes, so I don't know how accurate it's going to be in the end. You can see though, I've got it hooked up to the 1.5. Don't mind how these batteries are, it's just so I can, this battery on this side isn't being used, it's just so I can shove my probe in to get a connection to this battery. So you got your 1.55-ish or so, which is about what the battery reads on my digital meter. And so on the DC volt scale, I'm on the 1.5 volt scale, which kind of uses this one that is marked 15. That'd be 1.5, so then, for example, 1.4 here, etc. So if I go to the 5 volt scale, now full scale would be, this would be the equivalent of 5. You'd kind of use these markings, so that'd be 5.0, 4.5, etc. So we go down here, and it is reading just over 1.5 on that scale, so we know that range is accurate. And then it gets a little worse as you get lower on the scale, but now we're on the 15 volt scale. So again, we'd use this top set of markings, but use the numbers for what they actually are, and we trace it over to here, and we're getting just above 1.5 there if you look. And you go any higher and you're not going to see much. The 50 volt scale, it's actually reading about 50. It's reading actually not too bad. That's 5, so that'd be about 1.5 there. And then any higher than this, we're definitely not going to see anything. Yeah, it's meter basically at 0. So we know that the ranges are working correctly here. So the next step is going to be to calibrate the AC voltage. This is one of those don't try this at home kid moments, and I'm trying to calibrate the AC, which basically tells you to connect your probe to wall voltage and calibrate it for whatever your wall voltage is. They say 110, I believe, in the manual, which is not really true anymore. Right now I believe on my meter there, I believe it says 121, so I should be calibrating it for 121. Regardless, I've got it hooked up in a kind of scary way at the moment, so again, this is a don't try it at home moment. What am I reading here at the moment? I'm on 150 volt range, so that would be about 90 according to this. So let me adjust that. Well, I can't quite get the reading I was hoping for on this. Best I can do is about 108 on the display, and I'm getting about 120 at the wall. The funny thing is, when I change my ranges, and I'm going to put the camera down very briefly here. When I change the range to the 500 volt range, the number I get is actually really close. Look, almost exactly. It's the 500 volt would be using that 50 volt scale, so 10 plus 2 more ticks would be 100 plus 2 ticks is really kind of 120 there. So in that aspect, this is actually reading correctly on the 500 volt scale. Possibly the precision of some of the resistors in the scale select has kind of gone out the window. Again, with the DC I was doing, we weren't really up that high, so I wouldn't notice a problem in the 150 volt range with the DC we were doing. So that could be it, or it could be something else maybe, but just a good test there. So I think it's pretty close. I may tweak and play with it a little more, but I'm kind of hoping not, because I won't be using this to measure AC voltages in the hundreds of volts. So can put it back together here and kind of get it straightened, set up again and straightened out. Well, I've done some more playing around with this thing, and I think I've got it basically working the way it should on the ohms function, and I'm testing out a 100 ohm resistor, and as you can see, it sits all the way to the right at infinity where I've adjusted it, and I'm on the R times 1 scale. So let me touch it there. You're basically getting right around 100, and again, as you're over here, it's a little less accurate. You really want to change your range so that you're kind of somewhere in the middle here. So I'll do the times 10. So it basically means whatever you're reading on the scope multiplied by, or the meter multiplied by 10. So 10 exactly times 10 is my 100. And I've checked this resistor with my digital meter, and it is 99.8 or something, right around 100. Okay, there's the times 100 range, and it's close to 1 there. And then if I do times 1,000, I probably won't see much. Yeah, you don't see much at that point. So, you know, probably the times 10 range for measuring this particular resistor is kind of your best bet to get an accurate reading, and it does. If it's right in the center of the scale here, it's probably your most accurate. So, but either way, it seems to be working okay. So I'm actually very happy with this. I probably won't be using it to measure much resistance, but it's good to know that it works. So this is just another piece of test equipment that I can put on the shelf and use when I need to, and you'll probably see it in another video someday. There it is, the Heathkit VTVM model IV11, or sorry, IM11. Thanks for watching.